Okay, let's dive right into this explainer. Pop culture has really painted this picture of absolute certainty when it comes to crime scenes, right? For decades, we've literally been conditioned to believe in flawless forensic science. But today, we are dismantling that myth. We're going to rank the 5 most famous forensic techniques from worst to best, and use the actual data to separate fact from TV fiction. Our historical quest for real empirical proof actually began way back in 1247. A man was found dead with these elongated wounds, and a local official decided to solve the murder with a surprisingly clever method. He basically had all the village farmers lay out their sickles in the town square. As the morning heat rose, flies began to descend, but they swarmed just one specific sickle that was coated in invisible blood, which prompted the owner to buckle and confess. It's a wild story from a book called The Washing Away of Wrongs by Song Shi, and it's literally the earliest record we have of an empirical approach to forensics. But to see how far we've actually come since the 13th century, we're going to systematically evaluate modern forensics. Here's our roadmap for the ranking. First, the forensic illusion. Then, the bottom tier. After that, the middle ground, followed by the fingerprint fallacy, the DNA paradox, and finally, the future of forensics. Let's get into it.
Starting off with Section 1, the forensic illusion.
So, we are constantly told that DNA evidence is used in more than 90% of investigations, and fingerprints in over 70% of murders. We're basically taught these techniques are foolproof. But in 2009, the National Academy of Sciences published this massive 350-page report that completely shattered that illusion. They declared that, with the exception of nuclear DNA analysis, almost none of our forensic methods are rigorously scientifically proven to connect evidence to a specific individual. Some tests, they bluntly stated, don't even meet the fundamental requirements of science. So let's start ranking these techniques based on that pretty harsh reality. Which brings us to Section 2, the bottom tier. Starting at the absolute bottom of our ranking, we have microscopic hair analysis. For a long time, well before DNA testing was widespread, investigators would look at the rough, fish scale-like structure of a hair's surface, or how its pigment was distributed, to claim a definitive match between a suspect and a crime scene. But listen to this staggering failure rate. Out of 268 FBI cases that used hair analysis against defendants between the 1970s and 1999, an astonishing 96% were later declared false matches when re-examined with DNA evidence. 96%! In some cases, highly experienced FBI examiners literally couldn't even tell the difference between human hair and dog hair. Tragically, 33 people had already been sentenced to death and 9 executed before these errors were brought to light. Today, the FBI only uses hair evidence if it's explicitly supported by DNA. Tied for the absolute bottom, bite marks are equally terrible. The whole theory assumed that if dental records can identify a deceased person, then bite marks on a victim should easily identify a perpetrator, right? Well, skin is a squishy, soft medium that distorts heavily under pressure. In a major university study, researchers made 89 bite marks in cadaver skin using a set of model teeth. The result? 0 out of those 89 bite marks matched the measurements of the original model teeth. Just imagine your entire life being on the line based on a technique where 0 out of 89 tests matched. Yet, despite this complete lack of scientific reliability, courts actually still accept bite mark evidence today simply because the justice system prefers consistency in historical precedent. Unbelievably, they've been used as recently as 2025. Moving up the ranking, we land in Section 3, the middle ground. Here, we're looking at blood stain pattern analysis. The core idea is that when someone is injured, you can use physics and biology to essentially rewind the clock, looking at how the blood pools and drips to extrapolate exactly where it came from. But the evolution here is fascinating. Early 1970s analysis, pioneered by a chemist named Herbert Leon McDonnell, relied on simple basement trigonometry that totally ignored basic physics. By just assuming blood traveled in perfect straight lines, analysts would often wrongly conclude a victim was standing up. But modern analysts absolutely must account for things like gravity and drag. When you factor those curved trajectories in, the origin point lowers significantly, often revealing the victim was actually sitting down. And to complicate things further, biological factors drastically throw off the math. Blood viscosity varies wildly from person to person. For example, men generally have a 15% higher concentration of red blood cells, which completely changes how their blood splatters. Because of these variables, and the fact that the exact same stain shape can actually be made in multiple different ways, analysts end up reaching different conclusions about 8% of the time. The field is honestly only now improving by implementing modern 3D fluid dynamics software to try and map these incredibly complex scenes.
That brings us to Section 4, the fingerprint fallacy. Stepping into the top two most relied upon methods, we really need to talk about fingerprints, a technique trusted in over 70% of murders. But before we get to modern computers, we have to appreciate the incredible history here. To organize millions of prints long before the digital age, 3 officers in 1890s Calcutta brilliantly invented a physical classification system. They built 1,024 wooden pigeonholes for sorting based on patterns like whorls, which are those spiral patterns, as well as plain arches and tented arches. By categorizing fingerprints this way, they created a massive physical database that became the global standard for the next century, famously adopted by Scotland Yard. Today, of course, we use digital databases. They focus on minutiae, which are the specific microscopic points where fingerprint ridgelines either split or end. But here is where the fallacy really begins. The database doesn't actually make a definitive match for you. It just uses these minutia points to pull a list of maybe 10 to 40 potential matches. The final, highly subjective decision still completely comes down to a human examiner.
And that human element introduces a massive vulnerability: conformity bias. With 42% of fingerprint requests openly including bias in context on the submission form, like a suspect's race, age, or criminal record, examiners can so easily be swayed by what they expect to find. This famously led to the false imprisonment of Brandon Mayfield in 2004. After the Madrid train bombings, FBI examiners were 100% certain a fingerprint on a detonator bag belonged to Mayfield. But Mayfield was an American lawyer who didn't even own a passport. The experts were swayed by bias and the massive high stakes of the case, matching a print to a man who had never even left the United States.
Now for a runner-up, Section 5, the DNA paradox.
We finally arrive at the climax of our ranking: DNA analysis. It's the presumed silver bullet of the justice system, yet it actually carries a massive hidden paradox. See, modern DNA testing is so incredibly sensitive, it can solve a cold case with just 0.4 nanograms of genetic material. But this extreme sensitivity creates a total nightmare of accidental touch transfers. Take the terrifying case of Lucas Anderson in 2012. Paramedics treated him for intoxication and took him to the hospital. Later that night, those exact same paramedics responded to a murder scene, inadvertently transferring Anderson's DNA from their equipment onto the victim's fingernails. Anderson nearly faced the death penalty for a murder that happened while he was completely immobilized in a hospital bed, all because of microscopic touch DNA.
And the most common source of error here comes from DNA mixtures. These are samples containing overlapping genetic profiles from multiple individuals. Think about it. If you touch a door handle, your DNA is there, but so is the DNA of everyone else who touched it. Labs are forced to isolate specific short tandem repeats, or STRs, from this chaotic cluster of data. Trying to interpret a complex mixture is exactly like trying to single out one person's voice while 5 people are screaming at you simultaneously. It is incredibly difficult to confidently identify which DNA peak belongs to whom. So, just how bad is this mixture problem? Well, in 2013, the National Institute of Standards and Technology sent a deliberately complex 4-person DNA mixture to labs all across the US to test their accuracy. The results were frankly terrifying. 69% of the labs got the analysis completely wrong, only 21% deemed it inconclusive, and a mere 10% actually got it right. And yet, there is still no lower limit on the quality or quantity of a DNA sample that labs are legally permitted to analyze. Let's wrap things up with Section 6, the future of forensics.
It's undeniable that it is still much better for us to live in a world with forensics than one without it, but we really have to clearly acknowledge its limitations. Given that DNA can never safely be taken out of context, and that human bias practically infiltrates every single level of analysis, from hair to blood to fingerprints, I want to leave you with this provocative question to ponder. Knowing its deep flaws and biases, is it still fair to call forensics a true science? Science is all about drawing the best possible conclusions from the information you have until you discover something better. The data clearly shows us that the guardrails need to be fortified and that we still have a whole lot to learn. Thanks for joining me on this explainer, and I hope this helps you look at the evidence just a little more closely next time.